from cognitive psychology and computational musicology can help understand cognition in ways only possible with music. He commits to an interdisciplinary approach grounded in music theory, but works extensively with computer science and psychology. Working between these areas has led to professional affiliations in each of his areas of expertise. Relevant to this talk, Dave also spent a year as lead instructor of data science at a coding boot camp in London. He currently works as a postdoctoral research associate at the University of Amsterdam in the Music Cognition Group. Welcome, Dave.
Thank you very much. All right, so hello, and thank you very much for having me today. I'm very excited to be able to speak with everyone. Thank you. Thanks for the lovely introduction. I really appreciate that, and especially ending with noting that I'm currently a postdoc working at the University of Amsterdam as part of the Music Cognition Group, which might throw up a red flag given the title of this talk, right? So why is someone who's working as an academic giving a talk about transitioning to a career in data science if he's working as an academic? Shouldn't they have got a speaker who did a music psychology related PhD and then now works in data science for something like this? So if you thought that, of course, kudos to you. It's a great question that I can answer both retrospectively and prospectively to start off the presentation here. So prospectively, as in looking to the future, basically, statistically speaking, most early career people, meaning PhDs, postdocs, I imagine sort of the majority of people attending this call, probably won't stay in academia. And at this point, hopefully it's not too shocking to hear that. I remember being told this when I started my PhD around 2015. And several years later, things haven't gotten better. So I actually found a figure from several years ago that shows the same type of trend that's happening now. And it's just a fact that there are more people graduating with PhDs than there are university positions. Of course, some of us will go on to work as academics, but not most of us. And spending so much time with statistics myself, I know that, of course, the odds aren't necessarily in my favor, even if I really, really, really wanted to do this, and I was absolutely set that this was the career for me. So as much as I am an optimist, or a reality denier, as some people might say, about many things in life, I think that having a firm platform to sort of step off of employment career-wise is something that has really been on my mind for the past several years. And I just want to give a bit of background about that before getting into more of the advice, just to sort of, I think, relate to maybe what a lot of people, I think, are feeling on this. So, of course, getting off of the academic ladder at some point is not the end of the world. You just end up doing what a lot of people, or a lot of academics, like to call an industry job, or as most people like to call it, just a regular job. And of course, there's lots of different jobs you could do. You could work as a cash register clerk, street sweeper, receptionist, barista. You could work at a theme park, take an odd job as a taxi driver. But the thing is, after doing a PhD, the chances are that you kind of like want to keep doing research. A common sentiment that I hear from a lot of people, and also feel myself, is that you didn't spend the last several years, right, of your life learning all of these skills in order to do a job that you could have just started the day that you started your PhD, right? Which leads to people wanting to say, well, I want to stay in something researchy. Data science is something kind of like that. And there are a lot of researchy type jobs out there. So today I'll be talking about data science because it's something I have the most experience thinking about. But there are also other types of jobs in this world, like UX researcher, as in user experience researcher, behavioral scientist, market analyst, data analyst, something like that, where really just what they're asking you to do as part of the job is to answer, act, and think about important questions relevant to business operations. You're still doing research, just sort of not on the slower timescale of 3 years of a PhD, and not on the niche topic of your PhD. So if you're about maybe like 30 when you finish your PhD, I'm imagining this is maybe the median age of a PhD grad based on that other chart, and you plan to work on to the basically retirement to the age of 65, that sort of means that you have another like maybe 35 years of work ahead of you, right? So I think it's good to start thinking now, especially when you have the flexibility, about setting yourself up to work in a field that's kind of like what you like to do, since you have to do it every single day for the next however many years, knowing full well that this might change. And of course, there's also good reason to think about doing a data science role, in that if you look at the people who have made this swap, almost no one seems to regret it. And of course, there's a massive selection bias into what shows up on my Twitter feed and the people that I talk to. But based on just some of the sampling of tweets that I've seen just in the past 2 weeks, when I wanted to show some empirical evidence for this, I was able to remember the people and names of people who do talk about this. What does it mean to go from being an academic to working in data science? Okay, so that's it prospectively. So of course, this is all fine and good, but why should you listen to me about this? And where's the bit about open science and whatnot? Well, to give a bit of a background on myself, I'm also a music psychology researcher. I come from the conservatory tradition, so I'm a trumpet player, and I actually did my PhD in music theory, not psychology or neuroscience or computer science. I'm very much a self-taught programmer, which is apparent if you've seen a lot of the code that I've written. But the questions that I'm interested in require tools from these disciplines, which is something I imagine a lot of people in this room relate to. Simultaneously, during my PhD, during my PhD, because of what I was interested in research-wise or scientifically, I ended up learning a little about stats and coding at first, because it was related to the research questions I wanted to answer about melodic memory. But then basically, to make a long story short, I kind of went to a talk like this one, where someone talked about how difficult it is to become a music theory professor. So you can read these the dated blogs from back in the day. And around that same time, I also happened to notice the way that you filter jobs on one of the websites for people who were learning R, which I came across when I was starting to learn, basically filtered salaries by like over and less than 100,000 US dollars, which just like totally blew my mind as a master's student. I was like, wow, these people are like making like tons and tons of money if they're good at this. So the realist in me basically said, okay, well, maybe I should try to learn more about R and stats and all this like data sciencey stuff, just like in case things don't work and I can't get an academic job when I'm done. So of course, I'm glad I did that, because when I finished my PhD, I couldn't get an academic job. Living in the UK at the time, and basically just wasn't able to secure an academic job or a postdoc. At the time, there was a position for this instructor position at this data science boot camp. And turns out having a fair bit of knowledge about stats and programming and a fair amount of classroom teaching experience was quite helpful. So these are all things that you can hopefully pick up during your PhD. So maybe this would be helpful. So then I ended up basically spending a year after my PhD teaching at Flatiron School as the lead instructor of data science in London, where my main job was to take people with minimal, and I mean very minimal, experience in all things data and help them get to a point where they could work in data science broadly defined, which I think qualifies me to talk to a group of very smart, savvy, receptive people who might want to walk a similar path. And it was at that time I learned all this stuff about like, how do you actually then make this transition between like, I haven't necessarily done tons of it, but I'm quite interested in it, and actually going out and doing it. I also still do a fair bit of work in this space with some data science consultancy in the education space too. So I try to stay quite updated on this despite doing research at this point. So of course, all the advice I'm about to give that I've learned from this time comes with a fair bit of survivorship bias. Of course, just because it worked for me doesn't mean it's going to work with you, work for you. But with that as a backdrop, hopefully you'll be open to the points and suggestions I'm going to make. And I know I'm going quite fast here, but when I recorded my talk last night, it ended up, I think, going for like an hour, even though I wanted it to be for 30 minutes. So I'm going to try and breeze through as much as I can. There's a slower version that I've recorded for myself online. So if you feel like I've blazed past something and you want something in more detail, more than happy to send that link. But I'll try and get through all my slides within my allotted time here. And then we can have a chat for people that do have questions. And I'm more than open to answering stuff in the chat as it does come up, or if you want me to explain something more fully, or if I'm speaking too quickly, please let me know. I'm kind of on autopilot here as it's at 8 a.m. And I have my text here as well. So I just want to take a bit of a break for myself before barreling back into it. Okay. Okay, great. So where's the part about open science, data science? Why did I talk so much about myself? Well, in some ways, I just wanted to give people a bit of a background about myself, to sort of be, ghost of Christmas future, right? This could be you. You could finish your PhD and something might not necessarily work out in terms of an academic job. So it's good to be prepared. It's a massive selection bias in the sense that, like, if you only meet people who go on to become professors and you have no one who sort of, works in industry, quote unquote, you're going to believe it's a lot more common for people to go on and continue this route than it is to like go off and do something else and then sort of lose touch with this community and not come back, which is this position I find myself in. Okay, so the first thing I basically said when I was going to do this talk, based on the description on the website, was to make this big argument about why music psychologists should adopt, learn, and use tools that exist at the crossroads of open science and data science, and talk about why this is good for us as a community. And when I say data science, kind of what what I'm talking about is learning a program, an open source programming language. So something like R or Python, or even learning how to program like a web experiments and using a library, a JavaScript library like JS Psych. So you're like learning how to program and think about learning how to write your thoughts down in code, as opposed to using some sort of proprietary software. And I thought this was going to be like the first half of my entire talk and make this big narrative about the overlap. But I've just tried to basically shorten it down and include it in this diagram, right? So were you to learn these tools, it's good for you, in my opinion, because of course it increases employability in non-academic jobs. I'll talk more about this in a second. Learning to program one language makes learning another one easier. So you don't have to get too caught up at first, like, oh, should I learn R? Should I learn Python? Honestly, it doesn't matter too much. Of course, there's certain caveats about that. There's then no need to require additional software to do your work. So if you're tethered to a software, you can only do one type of analysis in one proprietary software. What happens when you don't want to pay the licensing fee for it? You kind of sort of lose your superpowers in some way. And of course, this also avoids duplication of work, because if you can write out a script for an analysis, you don't have to click through it every time you want to do it. And there are other reasons too. These are just a few that I thought of. Learning these tools is also good for science, in my opinion, because if you use open access tools, it leads to easier data access, easier access to code, greater transparency, reproducibility. It's easier for others to find errors in your work. And I think that transparency is the foundation for trust in a lot of analysis. Again, there are caveats about this, like what does it mean for things to be accessible and reproducible? We could debate that if we want, but I'm not going to get too hung up on it now. I'm just going to sort of assume that you agree with me and go on to thinking about what would be next then, right? Without, of course, addressing the other side of things, which is, what happens when you think about staying in the proprietary software world? Do you feel like you're going to be left behind if you don't necessarily know this? So of course, this switch is not exactly easy, right? I'm not saying, oh, you just have to do this. It's like something that you would do, just in your spare time to like take a couple of weeks and now you do it. Like the reality is it's way more difficult to do this, especially if you teach, right? You have course documents set up in SPSS or M+. And if you don't really know it well, you're not able to like totally support your students when they're learning. So there are pedagogical challenges in that, like if you swap your stats course over to R or something for this sake, students are then also having to simultaneously learn stats and coding at the same time, which can be a total nightmare. So in terms of university infrastructure, I think you have to do what you need to do to keep your sanity and your job and your daily work fine, right? But as much as I love my academic job, I know it doesn't love me back. So as someone who has had an end date on pretty much every single contract for the past 5 to 7 years, I've learned that to stay sane, you need to do a bit of like self-care and prospectively learn things that will allow you to stay afloat in the world of research. So as we saw on the previous slide, assuming you haven't been living like under a rock in terms of like the replication crisis and open science and all those types of things, I think hopefully it's an easy argument to say why you should learn something like maybe R or Python, right? So I try to resist putting memes and things, but I thought this was too funny. So, I would, if you learn these tools, I receive a more accessible and transparent ecosystem for conducting science. You would, of course, receive a commercially in-demand skill set that will only enhance your ability to answer empirical questions and improve your employability when your limited term contract ends, right? And of course, I made more arguments for this because I was like, I'll just, keep going on this. So if you're more of a quadrant person, maybe you could think about it like this. You either learn or not learn the tools of open science at this overlap, or you stay or don't stay in academia. If you don't learn these tools and stay in academia, I think it's harder to commit to open science practices. It'll be harder to compete against job candidates who do know these skills and how to program. And you won't be able to teach classes using these tools to students who would benefit from learning the basics. I know it's a bit doomsday. I'm sure there are other reasons as well, but of course I'm making an argument here. If you don't learn these skills and leave academia, of course, it'll be harder for you to hire someone because no one wants to hire an employee who, to do what they do, needs tons of proprietary software. You can't just code up an E-prime experiment and ask people to do that as a proxy for interacting with your real-time website, right? You're going to probably actually have to work with software developers as a part of a product, and you want to be able to look and think sort of in code in the sense that like it's going to make you a better colleague if you're able to communicate that. Doesn't mean you have to be a professional software developer for this, but you want to make the effort to make that connection and speak this sort of common language, so to speak. Of course, the other side is learning tools and staying, which is of course the same, hopefully in some ways, but better. And then in industry, if you go on for that after having learned these tools, you'll hopefully have learned the basics, right? Again, you don't have to be a master at this. Because you want to take what you've learned during this time with the support and structure that you have, and now you're in a position to learn more and learn more rapidly. So the rest of this talk assumes that you're kind of in the quadrant that, you want to learn these tools. You maybe don't know them like totally at this point, but you're probably going to leave academia at some point, right? You're going to do plan D and go for data science. So the rest of the talk isn't how to get these skills, right? I'm not going to not leave you with some resources. This is a small enough group that if people have questions or want suggestions on how to do this, like just send me a message, or maybe we could talk about it afterwards. But here's some resources that I read during my PhD that I thought were super helpful. So assuming you are in this space, what's some advice? How do you actually start like doing it and moving your creating the mental models about what it means to not be an academic and move towards this data science world? Okay, so how do you then break into data science? Okay, so at this point, I imagine you're a PhD student who has put in the work maybe of learning this pre-discussed overlap of open science and data science and are thinking about doing a non-academic job. So I'm going to try to basically take all of the advice that I learned to give to students to help them get jobs. And they did, of course, go on to get very cool jobs in data science, which I thought was quite impressive given where they started from. And I want to basically, I'm doing this with a persona in mind, right? I imagine you're a graduate student or postdoc, you've drank the open science Kool-Aid, you've accepted you might not become a professor, and you want to take steps to improve your practice of the sciences and your midterm employment prospects, right? So important to note here, I'm not talking to this generalist audience. This is a really important skill to learn when talking, especially to non-academics. We can't just assume that everybody kind of knows everything and they get why we value everything. We want to be really explicit and direct with people to communicate who we are and what we have as value to people that might want to give us a bunch of money, right? Okay, so here's my list. I'll try and blaze through it. We can always come back and talk about it more afterwards. Okay, so number one, I'd say start now. So the best time to start thinking about working in a non-academic job is now. You can use the fact that you won't even be able to apply for non-academic jobs right now to ask questions and network, right? You want to finish your PhD. You're not dropping out anytime soon. And that kind of gives you in some ways a bit of a barrier to be like, if I reach out to someone, there's almost not a pressure to really understand everything, because you're not doing that right now. You're planting the seed for several years maybe down the line. Here, of course, it's important to say explicitly, you're not expected to know everything when you're learning. And you can use this as an opportunity to ask people. You want to make connections before you need them, which will hopefully build trust in your network. So not just asking, you don't want to be someone who just asks for favors at the last second. You finish your PhD and you're like, oh, shoot, can't get an academic job. I'm going to message literally every person that I know that does something kind of like what I do, right? It's just like a bad look, and people might not want to hire someone who doesn't have this sort of more long range thinking that they do. Learning a new set of skills takes time on top of everything else. So I'm not saying this is a perfect overlap, right, between your PhD, or else I just wouldn't be giving this talk. It's like the adage from the music school, if you want to be a classical trombone player, you need to practice 4 hours a day. And if you want to be a jazz trombone player, you need to practice 4 hours a day. But if you want to be a classical and jazz trombone player, you need to practice 8 hours a day, right? So there's some overlap. Maybe it's not exactly totally additive, but this does take extra time and effort. But I think it's well worth it for both yourself and, again, for science. And of course, you want to do this and take advantage of the unstructured time that you have during your PhD compared to having a bottom line at a company. The next point is be a researcher. So what we value as academics is not necessarily what businesses value. And if you've never worked in a business setting, it's important to think about and research what that is. So I think it's important to, do that research, own this career change that you might make, just like you're learning new literature or a new method. And you can't expect this to be spoon-fed to you, right? So you can go to 100 talks like this, where people talk about moving to data science, but really you have to put in the work and figure it out for yourself and ask other people, as opposed to sort of just assuming that it's going to be digested for you in bite-sized formats, which I'm doing my best to right now. Okay, next piece of advice, I think people should try to separate your academic and industry identities, at least at first. So in thinking about this change and in self-reflecting, it's important to do a bit of a soul split, I think, and separate your academic identity from who you're going to get basically paid, what you're going to get paid to do. Too many junior academics seem to not want to let go of their specialty, which, of course, to be fair, it's been your identity for several years, so I understand that. But if you don't do this, it can kind of give off the idea that you might just want a company to pay you to do your research, but like under the lens of like business, right? So like your PhD on capitalism, like it's not the best look, and it's not the way to, I think, lead in terms of selling what you can do for what that job will be. So it's best to lead with the critical thinking and data skills that you have, and then pepper in your expertise in music and psychology as you see fit, as it pertains to the company and the job that you'll be applying to. To figure this out, it's really great to put yourself in the shoes of your employer. Say, if I'm going to pay someone a bunch of money, what are the skills I would want them to have? And of course, if you don't know that, you got to go back a suggestion and actually think about, do your research. What are you actually doing in this job, and why are they paying you money to do it? And this addresses this question I think a couple other people had about fit, where it's like, how do I know if I'm a good fit? Well, you really, again, think about what they might need as a company. It's always going to be different. Companies are at different stages, they're at different sizes. You have to do your research. And once you understand that, then you can go on to think about this more. Okay, know your audience. So I think it takes time. You want to take time to think about who your audience is every time you speak to them. Always assume that they're smart, but they just don't know the things that you know, which are quite obscure, given the fact you're doing a PhD. People like to be around others who make them feel intelligent. So anything you can say and do to, I think, help people with that is always going to build trust. And trust that other people will ask you specifics if they're interested, knowing that going too deep too soon often misses the forest for the trees. I'll talk more about this a little later. I think if you should be kind, and of course, again, be empathetic and think in your interactions with people, how can you help other people get what they want? So a lot of these interactions are two-way streets. The power dynamics don't necessarily exist in the same way as they do in academia. Of course, respect people's time. So in learning about data science, you'll ask people about their experience in the sector. This means asking people for coffees and whatnot. Respect this time by, of course, making sure when you do talk with them, you're not just asking them obvious questions that could be found in public. So you have a coffee chat with someone and you ask them what their company is about, but like there's literally an about section on their website, which you could have learned that, right? You don't want to betray the trust that you're trying to sell yourself on saying, well, I'm a researcher, I have really great critical thinking skills. But if you don't put in that work, I don't think it's necessarily a good look. Of course, strive to never be late for meetings, make it easy for them, and just know that you're always interviewing, even though you might not be in an interview. This is sort of more of a general networking question. I think your network is your net worth. So unlike academia with a limited number of jobs and grants, and this ideal lifetime appointment, which happens in the United States, companies grow, people change careers much more frequently than in academia. Also, if someone can help you get a job and it does work out, it's also a success for them. So this builds the reputation as a credible person, and of course reflects well on both of you. And people really want to help others who might help them. And remember to not always, of course, be someone who's asking. You want to check in with people every so often in developing your network. How do you do this? I know networking is easier said than done. You want to connect with people with similar needs or interests. Be visible and accessible. Of course, that doesn't mean you have to be performative, right? Like on Twitter, and that's like your networking, just tweeting, junk all the time. But you need to be able to be accessible in some ways, so people can see who you are and what you do, which we'll talk about in a second. Also, to build your network, you want to be asked to be introduced to other people via informational interviews. So if there's something you're genuinely interested in, and you know someone who's even semi-related, you just got to send them a message and ask them to talk. And I'll again talk about how to do that in a second. But also in networking, it's also important to try to help others whenever you can, because networking isn't about punching above your weight. If you're going to break into this sort of world, most of the important connections that you will have over the next 5 to 10 years are your peers who go on to do something similar to you. They're the ones that are going to help you navigate career changes and help you get referrals for jobs, not people who are several years older than you. So remember, you're playing the long game now, and it will benefit you later. Also, if you do your best to connect other people, so it's not always just you connecting with someone else, you often make yourself the center of a really network of good people, and that also, I think, bodes well for you in the long run. Worth mentioning, network is also not zero sum. So just because someone else succeeds, it doesn't mean that you lose. And then thinking more about, okay, how do you then communicate this? So what are you actually communicating? What are you trying to figure out? How do you show people that you could do a job in the world of data science? What are some good pieces of advice? I should have had a little section breaker here, but I don't. So the golden rule here is show, don't tell. So the big problem, now talking specifically about the world of data science, is that in some ways it's been democratized in that it's never been easier to learn about coding and programming and machine learning and things like that, right? So this is like great for learners if you want to learn stuff like this, but bad for people trying to hire. Why? Well, because you can't always tell when someone really understands something and when they have just sort of like parroted the knowledge, right? So the answer to this is to have tangible examples that anybody can see, right? Pointing back to open science, that demonstrate what you can do. When describing this, describing your work, you always want to include things that basically point to the magnitude and scope of what your abilities are as they stand at this one moment. So other people can understand basically where you're at. So instead of saying something like on your resume, like, oh, I was responsible for the data collection for experiments, you would write something like, oh, I've collected 20,000 responses on an online survey platform developed in Python, hosted on Amazon Mechanical Turk. So you don't have to know the specific details about the implementation, but most intelligent people kind of get what that necessarily means. And if they want to ask you more technical questions, they will, which we'll talk about more. So one key in standing out in verbal and written communication is also the key to this next piece of advice, which is only write basically what you could. So writing facts about yourself that only you could write. So in thinking about this, you want to put yourself in the shoes of hiring committees, right? And you see that, of course, there are many people who claim to be data scientists. You know, people are like computer engineers, and they read a couple of courses, do a course online, and they can regurgitate the job specs, but they never link to necessarily any empirical examples of how they match this. And the more you can do this, and the more you can show people what you do, right, through the world of open science, the better off you're going to end up being in the long run. I also suggest people try to avoid relative descriptions of skills. So try to not say things on your resume like beginner Python user or intermediate understanding of stats, because this means different things to different people. Examples of this might be, instead of saying like, oh, I'm an OKR user, you just say what you did with R, right? I used R to create data visualizations that were published in peer-reviewed journals. I developed Python software for segmenting audio. I ran some sort of mixed effects model to estimate customer spending, right? It's all about just giving people enough to start a conversation and get interested in you, as opposed to, of course, laundry listing or being too vague about what your skills are. And then my last bit of advice here is in communication, whether this is verbal or written, try to communicate with the data science sandwich. So I saw this advert discussed on Twitter a few years ago. I can't remember who it was, but they basically said, in talking about things and giving a story to explaining what you do, it's important to use this sort of 4-step process of talking about how to communicate your research. So the first step is the business or real world problem, right? So you're talking about in communicating your research, you had some general question that's sort of ill-formed, right? You had something that you wanted to answer about the world that's quite broad and could be answered in several different ways. But what do you do as a really smart person? Well, you take that question and you operationalize it, which is what we're like really good at as academic researchers, right? We see a complex problem and we figure out a way in which we could formalize this problem and move it into the realm of science, specifically here, data science. Whether or not those are different, another question. But once that's operationalized, you then, of course, do an analysis. You run some sort of statistical model, you do some exploratory data analysis, maybe you're doing some weird machine learning, output a whole bunch of parameter values, and you have to interpret them. And that's sometimes where academia stops, right? Because like really what we're in the business of, and I got this from watching some, I think Richard McElroy said this in one of his YouTube lectures on that Bayesian course that he's offered for free. So it's like, as academics, we're just in the business of quantifying uncertainty, right? We're trying to look at a system, think about the data generating processes, model it, sort of put some nice posteriors around the parameters that we're interested in, and then think about this in the larger context. But in the world of business, you often want to make, set things up in a way in which you can then make a decision or an action based on what you've learned. And if you can then wrap around from that real world problem to a specific action or decision that you make, it shows that you understand what you're kind of actually going to be doing on this job. So practicing taking something that you have done and putting into this format, I think is super helpful. Okay. So what's the final actionable listing of things you can do? I gave a bunch of kind of vague high-level advice. How do you then actually go out and do this at this point? Let's take about maybe 3 or 4 more minutes. I know I've gone a bit over on time, but there's just like so much stuff, of course, I want to say. And I've boiled this down to 4 pieces of advice. So 1, research a company. 2, ask for 5 cups of coffee. 3, write a hype man project pitch. And then 4, show off your work. Okay, what do I mean by these? Number 1, this is for people that maybe haven't had a non-academic job before. And I just say research a company, right? So find a company that you might want to work for. And then after reading a little bit about them and researching them, try to write out a summary of how that company makes money or makes revenue or makes value, right? You have to think about this and understand this at the large context before you can understand what you would be doing if you were to work at this job, right? Then you may want to find a posting at the job company, or find a job posting at the company, ideally one you want to work with, and then write out a summary of how paying an individual to work in this position would ultimately result in more value for the company, right? So if you don't create more value, if all the employees don't create more value for the company than they bring in, then the company folds, right? So your real responsibility is to create more value in the long run. You want to list 3 skills maybe that you have that might help this company grow, and then write a sentence linking each skill to that. And it's important to write this out because eventually you're going to want to come across as being quite succinct and direct in communications with people, as opposed to a talk like this, where someone just gives you a microphone and you rant for like 40 minutes about all the things that you have opinions on, which is not an approach that I would take if I was giving more of an industry type talk. We have a different culture here in academia. Okay, next one, ask for 5 cups of coffee. So the one here is basically message 5 different people, ask them for meet for 30 minutes to talk about their work or their company or themselves. So you might say something like, oh, hello, Dave. My name is John. I'm a second-year PhD student who's really interested in what you do at whatever company, fields, or maybe yourself. And I'm looking for, you want to ask for something very specific, right? You don't want to have other people do your thinking for them. So if I get a message saying, Dave, can you just tell me about data science? Of course, me being a softie, I'm always like, oh yeah, let me help you out, blah, blah, blah. But it's much more appreciated if you have a very specific thing that someone can answer, right? Because if they can answer it, it also makes them feel like they have basically sort of almost succeeded in the conversation, right? So you might ask them specifically about like, I'm interested in what type of skills your company is looking to hire in the midterm. I'm looking to learn more about some industry, like I want to get into audio branding, and I know SoundOut is an audio branding company. So I have some questions I'd like to ask you. Or you can ask people about how they got working in a specific company or industry. So as much as I tried to not talk about myself, I talked about myself for the first 10 minutes of this talk, which was like, in some ways, a bit narcissistic, but it's everybody's Achilles heel, right? So if you want to get a conversation going, just asking people, how did you get to where you got? Is a great way to basically just start a conversation. The next one is write a hype man project pitch. So I suggest people write as short a pitch as possible that describes a project, maybe your whole PhD thesis, maybe just a paper that you were involved in or led during grad school that shows off your skills. Write this pitch to a specific persona, right? Don't write it for a general audience. Think like, oh, if I was talking to a recruiter, what might they want to hear? If I was talking to the senior data scientist on a team, what might they want to hear? Which kind of gets you in that framework of like constantly adjusting what you're about to say. Write this narrative using the data science sandwich that I talked about earlier, and write down only facts that you wrote about yourself. So if you're about to talk about some melodic memory experiment you did, if you don't get into specifics enough, I ran this experiment on melodic memory. Well, I could have written that because I do stuff with melodic memory, right? You want to distinguish yourself and write things that are specific enough that the person you're talking to knows that you have some sort of ownership over the ideas, and you're of course going to get excited to talk about them. Leave out the boring details, trusting that other people will ask you these things, right? If you don't know what the boring details are, talk to other people, just wait till their eyes glaze over, right? Or, in talking to a lot of people, you'll figure out what's important and what's not. And then lastly, I would say almost most importantly, show your work. So take time to create a GitHub page for your Hype Man project, organize the code so it shows that you are a colleague who, sets things up in a sensible way. Write an executive summary, show off some data visualization skills, and be really explicit about why all of this matters, right? So something we used to tell the boot camp students is that you're not writing a detective novel. Put the most important information at the start of it. So here are some examples. I have a link to I think I could send this out. So this is literally the template that we would give people at Flatiron to kind of like show off their final portfolio project. It looks nice without even actually having to read any of this because it's actually mostly boilerplate text, right? But it shows that like whoever did write this, it was me, has some sort of idea about how do you organize something in a clear and succinct way that looks professional, right? Shows I know Markdown formatting. If you don't know that, really fantastic, of course, to learn. And then it goes in the order of things that people would find interesting. So you'd have your title, you link to your email. We suggest people follow what we call the Facebook approach when writing the README, which means most important information at the top, name, project, contact info. And then as you go down, the more details people want, the more that's there for them. You write an executive summary, you show off your data visualization. I've done this with one of the repositories, that was recently published in Music Perception. You do all this work, right? And you can't expect someone that's going to hire you is going to go find this journal article behind a paywall that's like about predominant chords and read it and be like, oh, this guy's a great fit for my company, right? You want to make things easy for them. So what do? You just excise out everything that shows off what you empirically can do. So what do I do with this repository? I basically have my code organized in a way that I'm not too embarrassed about. I note the things that would be sort of interesting, maybe either for reviewers or someone that might want to see where am I at with my data analysis and modeling skills. I have some ggplots that I'm quite proud of, right? So this shows pretty much like what I could do given a whole bunch of time. And I can talk quite extensively about any of these analyses, both in black and white and color. And I just have more, the other figures from the paper. So here's a figure from a principal component analysis that was done. And I also have this other clustering algorithm that a reviewer asked us to do for the paper. And there's not really a lot of detail on it, right? But if you're the hiring manager, you could basically see it and say, oh, I see you've done this clustering algorithm. Can you tell me more about it? And then we start a conversation from there. So the big takeaways are hopefully start early, show the magnitude and scope of your ability, show, don't tell, communicate with other people's needs and minds. Your network is your net worth, and try to ask for help along the way. I'm sorry I ran over, but of course, I just wanted to include all of this. So thank you very much for your time and attention. If you have questions, I'm more than happy to answer them now or at any point in the future.